In this problem, now we're given a cube root function, and again, we're asked to find the domain, graph it, and then to find the range. So we know the basic shape, but we're still going to need to plot some points. To start off with a domain, with a cube root, remember there's nothing that limits what value can be under the radical. And in this case, what's under the radical is just x, so there's nothing that limits what's under the radical is either. What it could be, if it were a rational function or a rational expression, then the denominator couldn't equal 0. If there were another radical, it'd have to be greater than or equal to 0 if it were an even root, so on and so forth. But in this case, there's no restriction on x, and there's no restriction on a cube root. So the domain is just simply going to be all real numbers. So negative infinity to infinity. And we'll go ahead and graph this by plotting a few points. We know the general shape. But let's say, and we want to try to make perfect cubes underneath here. The reason being is because if we can get a whole number value, we're going to be able to graph it more accurately. So let's let x be 8, or negative 8 to start out. If x equals negative 8, I'm going to fix that y real quick. If x equals negative 8, then the cube root of negative 8 is negative 2, and then negative 2 is 2. So let's label our axes. We'll go to negative 8. So 1, 2, 3, 4, 5, 6, 7, 8 to the left, and 2 up. And then what would be the next perfect cube we could look at? If we let x equal negative 1, then the cube root of negative 1 is negative 1, and it's the negative cube root of negative 1, so that would be 1. So we'll go to negative 1, 1, and then 0. And the negative cube root of 0 is just 0. 1, we're going to end up at negative 1. Excuse me. The negative cube root of 1 is negative 1, so we'll go to 1, negative 1. And then we'll look at 8 again on the other end. So if we put in 8, then the negative cube root of 8 would be negative 2. So if we go to 8, and we go down to negative 2. And then knowing what we know about cube root functions, we know the basic shape, so we just connect the dots knowing that basic shape. And then there's our graph of f of x equals negative cube root of x. Now, there's no restriction on the domain. And since it goes on infinitely, it doesn't look like it is going to get closer and closer to some specific horizontal line. It's just going to go on infinitely as well. In other words, the larger number we put in for x, the more negative it's going to get. The larger, or the smaller in the negative direction, the larger negative we put in for x. The more negative we put in for x, the more positive the output is going to get. So the range, as indicated by that logic and the graph, is just going to be the same as the domain, all real numbers, negative infinity to infinity.